kind of get this kicked off, I want to start with a few things. My name's Kevin at Microsoft. I'm a technical specialist, which just means I get to play a lot of technology, and I'm a big nerd. It's really the way it is. I would like to think that most of the things I've done up to this day have prepared me for this. I've dealt with a lot of the MPP and the big data, those kinds of scenarios. I write in 27 different languages. I understand a lot of networking, security, and IoT is ultra cool. When you work for a software and services company, which is truly what Microsoft is, and you find yourself soldering things on a motherboard, either things are going good or they're going bad, right? So it can go either way with that. So what I thought I would do, and when Efren asked me to kind of speak to this, have this opportunity, I want to kind of just flex a muscle just for a second. I want to kind of show some interesting capabilities. To me, IoT always starts with the business problem. Collecting data, that's interesting maybe, but that's nothing. I mean, if you're a business who wants to collect data with no real value beyond it, you probably won't be in business for long. So I want to change the way things are done. I want to show how we look at business first, and then we bring the right solutions to bear to solve the problem. Everything I show you is already blogged. I blogged everything this. I built this just for this particular night. So everything I've done is just for this night. And I want to share it with you, but I was thinking a while back, as I tend to do, I was thinking about the home security system providers. When someone buys a house, you have a home security system, it's monitored, right? How long is it monitored for? Well, statistics tell us it drops off to about 40 and 50% people drop off quickly. Why? They don't see value in it, right? They forget to set it. They don't set it, all those things. So I want to change the paradigm. Why should you arm your house or protect your house, whatever? Why shouldn't your house protect itself? Why shouldn't your house know you? So that's the thought pattern I went down. We have machine learning, we have great capability. It should do this for me. I should not have to remember that. I have a 9-year-old daughter. She rides a bus every day. She goes to school. She leaves my front door at 7 a.m. She gets back around 4 p.m., right? That happens every day, except Saturday and Sunday. And except days on like the summer, right? We should not have to set the alarm. It should just be organic. It should just happen naturally. My wife, she's a librarian. She leaves at a certain time, comes back at a certain time. I have my favorite bar pretty close to me, so I go there in the evening often. So these are normal patterns. These are things that just always happen. I want my house to know me. I don't have to understand and learn and set the alarm, and as I drive out the driveway, I close the garage door. None of that stuff should be a thought pattern for me. It should just happen organically. So applying technology, we solve this differently. So going back to a second, for the companies out there who provide monitoring service, right? They charge you some fee, and some things happen, and if they call you or whatever, all those things happen. You have people applied to that. These are things right for computer learning. These are things right to kind of show that capability. And the power of IoT, that's what makes us real. So that's really kind of how this plays out. So I was thinking through this a while back. How are we going to do this? What makes sense? I wanted all those patterns I just showed you to happen. Every one of them. So I wanted to build a system that would do that. And as every good architect starts with, you start the whiteboard or some kind of a drawing, some kind of scenario, napkin, whatever vernacular you like, don't care, right? You kind of start with that scenario. So I want to walk you through this, the logic, the concept. This is not copyrighted, patented. Take this, make money out of it, be happy, buy me a beer. I'm all down with that, right? So we'll start in the top left here is that we want to know when a door opens. So your house has these little magnetic things. That's not new, right? So we want to know when that happens. And we see when people come in the front door, probably not the second story window, but the front door, the garage, and all those kinds of scenarios. So we understand that happens. And in the IoT space, we have this concept of hot path and cold path. Cold path is just historic stuff, right? We know that every day my daughter comes home at 4. Period. That's a fact, right? That's not really open for discussion. When she comes home, she opens the front door. Those are just things that happen, right? So the very top, we look at just monitoring all those areas. We look at little Arduino boards or something, right, that can pick up that. These things are dirt cheap, $3, right? And it should only be $1. But we'll start with $3, right? Well, Wi-Fi built in, all those kinds of things. Simple, simple, simple stuff, right? C++ code on there? Well, life is simple. You know the logic, right? If door opens, do something. If door is not open, just record that status, right? Because the door should be closed every other time. So we look at the very top where we send that data into IoT Hub, right? Azure IoT Hub sits out there. We use MQTT protocol, blah, 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 right? Simple, simple stuff. And we're always looking at it. We're always sending that data to a blob storage so that we can train, we can use the muscle of that and figure that story out, right? So the very top shows that, but in the event that someone comes in my front door at noon, noon's not that 4 or 7, noon's a very different scenario. Do we call the police instantly? No, that doesn't make sense. We want to understand what's a pattern and maybe go through the next process. So if there's something that statistically speaking should not have happened, and we know that statistics by machine learning, very simple stuff there, should not have happened, then we want to take the next step. And in this next step, we're going to verify that's who that person is. And in this scenario, we use what we call cognitive services. I'm going to take a picture of the person. Is this the person with a high level of confidence who I believe they are? Okay. People change. I lose a lot of hair, I get a lot of gray, all those kinds of scenarios. I don't look the same way I did when I was 18, right? So the cognitive services should always learn, right? As I change, grow a beard, shave, all those things that happen, right? So we kind of work through that scenario. We take the picture and we figure that. So we will look. If statistically speaking that door should not open, we're going to do a facial recognition. And if that facial recognition matches who we believe it to be, we're going to now update both models. The model of the person, the model when that should have happened. If that does not happen, meaning that a lady walked in and did not match any of the people who live in my house, we're going to take the next step. And in this scenario, we got to notify the police or do something like that, right? So that's kind of the working model. That was kind of what I was working for. That makes sense to me. First level of defense is statistically should have happened. Second level of defense is I want to verify through some method. Pictures aren't the only way, right? I could have used voice. I could have used so many other things. But pictures were simple, right? And pictures are not absolute, but pretty darn close, right? Kind of works through that scenario. So that's kind of it from that perspective, showing the hot path, the cold path, and when things happen. Let me pause right there on just that approach before I jump into a couple of demos of that. Any questions of that? Any clarification? Any things I may have missed? All right, then we will jump right into that. So to build that, and this is the power of Azure. I'm not going to brag too much about Microsoft stuff, but I built everything I'm showing you here in less than a day. Everything I'm showing you is that quick. Now, I will also say it was useless day one. Why? Because we had not trained the model. It didn't know that my daughter came home these days. It didn't know that weekends happen and holidays and all those kinds of things. Day one, it's relatively useless. I don't have enough data to train the model. But day 90, day 180, day 360, it's a darn good model. Kind of make sense? It's pretty simple stuff, and we'll jump through that. In the blog here, I've got a link that kind of walks through how we do everything, and I have a link where you can follow step by step to get the guys set up in that scenario. But ultimately speaking, it's really simple concepts. There are very few things I added to this. This is the strength of Azure, our IoT Hub, Stream Analytics, that's an in-memory thing where we take things out and determine certain scenarios and move it to the right place. Machine learning, that's where I run certain algorithms to figure that story out. Function, that's our equivalent of Lambda. That's the fact that I have code, I have concept, I have something I need to run. I don't really care about setting up a server, don't need to care about middleware, and none of that stuff. I write in the language I prefer. I wrote this one in C#. I had someone else challenge me in Node.js. Didn't care. I wrote in both. Just don't care, right? Simple stuff there. Cognitive services, that's our ability to do that. Facial recognition, we can do video, all kinds of scenarios there. But these are the simple components that were brought together to solve this problem. And so we'll kind of jump through just some of that scenario and kind of take a look at it. I have here a demonstration, just a contact, right? There's nothing special. You know what's in here, right? That Arduino board, there's nothing special. When I lift this up, we will see that he'll actually send he'll actually send a command. I'll take a look at the last one I looked at just for a second, and we'll see that he received something, and he said that there's a 99.938%, I'm reading it to you, I'm sorry it's so blurry, that door should not have opened at that time. Now, I do my development kind of during the day. I was doing this demo a while back. It's failing miserably, as all demos do periodically, right? You gotta learn to deal with that. Why was it failing miserably? Because I was opening and closing the door when I normally did my demo, right? The model was doing what it's supposed to do. I just had, failed to consider that. So what we'll do is we'll kind of jump through that. So I'm going to open the door. Should not have happened. I'm going to sit down here, and what we'll see is the Pi will wake up, and they'll communicate, and he'll take a picture of me if my face is where it should be. And the red light goes on, off. Okay. Stay. All right, so now we've actually gone through the whole process, and I'll explain it in just a second. But let's look at what just kind of happened there as we went through that whole scenario. Is that it had a 99.977% chance that door should not have opened. We calculated that in a web service in a fraction of a second. We went to the power of machine learning and said, you tell me, should this door have opened? Okay? And it told me, not only no, but hell no, should not have opened, right? So then we went to the very next one and said, okay, should not have opened. So then we'll actually go, we will verify the person, and we send a message that says, take a picture of the guy. So it said 99.9% chance should door not open. Take a picture of the guy. And it identified me with a 67% confidence. Show that right there. Okay. Machine learning is not 100% exact. I look very different than I did when I started this whole thing. I uploaded a bunch of pictures without a beard or anything like that, so very different scenario. So I can train it what it looks like now. But in this case here, it says 67% confidence, which is not high enough. And in that scenario, he'll actually come out and talk to me, and we'll send a picture. Let me see, can I zoom this? I can't. It says, warning, 99.977. I told you that percent of the door should not open. It identified me, used GUIDs there with a 67% confidence. I like where it's going here. It says male, age 42.6. I'm actually 44. No glasses. And I could have had things about smiling and whatever. But if we're looking at things like, I want a picture to send to the police, we don't care about smiling, right? We care about, I want a picture of the guy or gal. And maybe some info about him, white male, glasses, no glasses, age, that kind of scenario. What we see right there is we went through that whole process in about 6 seconds. Okay, that's the speed and the power of IoT and the fact that I opened a door, we went through those scenarios, and I got some debugging where I'm kind of showing that scenario, and it just kind of walks all the way through and it takes a picture of me and understands who and what I am, right? So we just kind of jump through that. I think the most interesting piece of this, we don't talk about this part much, but I'm going to, is all this goodness that I put together. All this stuff that I've just shown you up here, all this might, this flex, this power, what was the cost of it? Been running for 3 weeks. The cost appears to be $8. $8 to run everything I just showed you. That's the power of IoT. That's the great capability there, and it's $8, right? Less than the price of one of your beers you're drinking right now. That's the power of the cloud. That's the things of machine learning that we see in that scenario. Now, there's fractions of pennies in there. Don't misunderstand, right? There are certain things in there. But I was working up a model for a customer, slightly different, and to do one user, it cost me $8 a day to do what they were trying to do with one user. Some of the bigger things we're using. When it gets to the millionth user, and they want to do 5 million, I was at a fraction of a penny per day per user. The power of the cloud. This is the power of really any cloud. Let's be honest with you, I'm showing Azure here in this scenario. And it's the power of running at scale. It's a power of not having to set up an OS, not having to install a database, not install any of that junk. All this stuff here is sitting in blob storage, right? For lack of a better term, that's just, it's a disk in the cloud. If you don't really understand that, it's just blob storage kind of sitting out there, hanging out there. Machine learning, very simple algorithms we run. We expose those as web services. Therefore, you can connect them really quick and understand that. I glued some C# code together to kind of do things like, if, then kind of logic. Very simple stuff, not much there at all. And that's the power of delivering that type of capability. This can be very transformative right here. This is solving a problem differently at a dirt cheap price. So now think about the security systems out there When we can apply this versus having someone watching a red light, green light, and a knock kind of scenario, what if we had this stuff automatically happen? What if we had to reach out to the user or go through some algorithm of learning, right? So I think that's a pretty neat scenario. The next iteration of that says, what if there's a crime spree happening in my neighborhood right now, right? I want to tighten down the wrench a little bit. I want to do something a little bit different in that scenario. I can pull many other data feeds and data sources into that particular scenario, right? The simplicity of the hubs we're putting together, the functions, the data, that kind of stuff, and machine learning and cognitive services. Those things are what make it all happen. Now, in transparency, the price you're seeing on here, I got some of these things running in developer mode, right? We offer a free Azure IoT hub, 8,000 messages a day, no charge, right? That's what I'm running that on there. If I want to go like a millions of messages per month kind of stuff, I'd have to go up, that's $50, right? So it does go up. Don't think I can run a full enterprise off of this, but understand the power of what I just showed you at that price. Kind of make sense? I think that's the ultra cool area. In my career at Microsoft, I started the guy supporting Windows Server 2013, kind of stuff, 2003, sorry, and above, and all that kind of stuff. Interesting, did a lot of IaaS stuff. I can tell you, I don't do IaaS anymore. I leverage the power of PaaS, right? Platform as a service, and this kind of stuff right here. I leverage the power of these silly devices. Yeah, I got Pi's, Raspberry Pi up there. Interesting, fun device, maybe. Not an enterprise-ready device, but a fun device to prototype certain things, right? I've got other customers right now kind of looking at how can we take $3 is too much. I want to take this, make it much smaller. I've seen things like 12 millimeters in size, right? Those kinds of scenarios with a sensor on there and solving problems that you can't even imagine, right? This is a very transformative place that I see a lot of people working in. I see them dreaming. They use the word dreaming correctly here. Let's dream, let's talk, let's figure something out, let's solve some problems. The power of Azure, which is all there, is I just connect them all together. Pretty simple stuff there from that point of view. You know, now, full disclaimer, pretty familiar with Azure. You can imagine that, right? So it might take other people more than a day, fine, but it's real. This is real stuff right here. And we have other people running these kinds of scenarios, right? Using the computer vision to figure out, is this product right or wrong? Computer vision to say, should I stop my whole assembly line? Interesting stuff in that scenario. Let me pause right there. Any questions kind of over that? Yes, sir.
Are you using anomaly detection? I guess what I'd like to know is how you're training.
How am I training? How do it work? Let me see if I can get to the here. I wrote something on here talking about the right there. Look for yourself. The hardest part for people conceptually, and this is the walkthrough how to do it. There we go, right there. All right. See if I can see. Okay. All right. If you guys all raise your right hand, I'm about to make you all data scientists. Okay. I'm going to teach you machine learning in less than 2 minutes. It's going to be that simple. Okay. Start at the very top. Import data. You kind of get that, right? I need data to work on. Give me all the data. Okay. And then I'll select the columns of the data. In my scenario here, I didn't care about year. Year didn't make sense to me. I cared about day of the week because my daughter doesn't go to school on Saturday and Sunday. Kind of makes sense? This is kind of logical if you think through what columns I want you to consider. That's really what I'm driving to there. The very next, I split the data. Why do I split the data? Because I need to build a model. And does the model work? Well, how do I know? What if I ran data through it? That's exactly what we split the data, give some data to build the model, some data to test the model. Why might I do that? There's more than one model in the world. Some models are better than others. So in that scenario, I can split it, I can train the model, you see a 2-class boosted decision, and that's it, and I score it. That's it. That's all it takes. Can you drag and drop? If so, you can do machine learning. That's all we're doing right here. In fairness right here, when I think it's going to be in train the model, I tell it what column I want to predict. I want to predict door open and close, right? It's a bit value here, right? 0, 1, right? That's what I want to predict. So I'll go what columns to consider, what column to predict, and I'm done. I'm really done. At this point, I can at the very bottom say, create me a web service. Because I want other things to feed to this and to calculate. What's it gonna feed? Those things I told in select columns. Day of the week, hour, month, you know, all those kinds of scenarios, right? That's it. That's all it took to build a machine learning model. That's it. Now, models are only as good as the data they have. I tell mine every night or every day to retrain itself. Because remember, every day patterns may change, right? Buses come earlier, buses come late. Don't care, right? I can retrain the model as needed. But that's it. That's it. You're all data scientists. Congratulations. Update your resume. Okay. Relatively simple stuff there.
Your data that you're feeding is date and time for when the door opens.
Yes.
And then you're scoring, somehow you're also saying that these are legit, and these are not legit.
No.
Because if you never told
Slightly
me what
different.
wasn't, then
Slightly different. So let's say that I go to work every day 8 to 5. I don't, but let's just say that, right? My car always travels the same road, basically, because I'm a creature of habit, right? We're just looking at that. We're not predicting what's right or wrong. We're saying there's a high probability that Kevin's going to drive down the same road again. Make sense? I didn't have to tell what was right or wrong. That's for the model to figure out. So then they can say, all right, if I've driven down the road, same road for the last 6 months, it's Sunday. It's for the model. It's Sunday. What's the odds of him driving down the road? I'm kind of lazy. I don't really go into work on the weekends if I can avoid it. Just kind of the way I roll, you know? So the odds are bad that I'm going to drive down that road going to work on Sunday. Kind of make sense? I didn't have to decide that. I let the model look at the data and tell me things that I may not have noticed.
Right, but you fed it a set of data from, let's say, the front door that says that that it was open at a certain time, certain date.
Yes.
And then later you're feeding it, okay, the door open here, is that legit?
Yes.
And it's giving you a probability of it being within the accepted scenario.
You see step 1 is in all events. Door open, door closed. Every time it happens. Step 2, store the history. Cold path, we call that. And then, you can't see it. So, see train model over there? He learns from the data. So yes.
What do you do though when the door, how do you keep the model trained so that the door is adjusted and it can open? I notice that if it opens an hour later, you know, here it's okay. Because you would normally say that's not okay, but you've gone in and said, yes, that one is acceptable.
Yes.
So there's an interaction part of you as part of the training.
I have a good friend who's a real data scientist, right? I'm just a hacker. I have a friend who's a real data scientist. He says he doesn't believe any data not created by a machine. You can kind of get that. That kind of makes sense, right? Well, what are your sales going to be this year? Well, they're going to be, well, you know, we might, if we're classical salespeople, we're bloating the number, right? If we're pessimistic people, we're bringing it down, right? But he doesn't trust data not created by a machine. In that scenario, we let the data tell the tale. Now, there are exceptions. My daughter could be sick, right? She comes home early. Those things can happen, right? Martin Luther King Day happens once a year, and it's weird, and there's certain holidays that change, right? Those things are okay, right? In that scenario, understand, my model took a picture of me. I don't let you input data. That doesn't make sense. In this model, but imagine you go home and it says, Kevin, why are you home? And it says, repeat to me, Mary had a little lamb. Mary had a little lamb. Now I'm doing voice recognition of my pattern with a level of certainty of that kind of scenario. We don't put other data in there. It learns off the model. Which is why I said earlier, day 1, absolutely useless. Day 90, day 180, pretty good. You know, day 720, pretty amazing.
So what you're saying is if an anomaly occurs, it'll notify you of it, but that's not necessarily
Correct.
a big deal.
Correct.
Yeah, it's not normal, but she came home early today because the school out of snow.
Certainly. It snowed in Dallas. It happens once a year. I'll give you a second. I promise you, you're the next person. So yes, it does understand that. But if they change the bus schedule, right? Now there's going to be a very different pattern, and it will learn that. So we'll retrain the model. Great question. Yes, sir, in the far back. I'm sorry?
The question is, so let's say you monitor the pattern for 1 week. The door has been opened 100 times. But it closed for this time. So that you or something, right? given alert, based on the model pattern, saying that, okay, the door is open.
Yes.
So there's a chance of it getting open, right?
Yes.
And what about the accuracy?
Well, back to my good friend, doesn't believe any data that doesn't come from a machine. Let's say I have people. We had hailstorms in Dallas not too long ago. I'm sure you guys had some down here, right? You can imagine people I had in my house painting and all kinds of stuff, right? Statistically, that was an absolute crazy thing for this, right? That was not good, right? So in that scenario, it had to verify or notify me. There has to be some kind of a check valve in that scenario. That was a bad scenario, and the fact that it statistically is wrong. And once again, over 180 days or a larger model, this will actually start to trend where it should be, based on your patterns, right? So it's not absolute. And it always talks about the level of certainty and a percentage of accuracy. And in every one of my Azure functions, I tell it what is acceptable. And I told it, for this demo, I told it had to be 99%. But more realistic, you see on my item here, 75%. Those are levels of risk I'm willing to take in that scenario. And I can always just say, take a picture too. Right? So that's it. Can I answer your question?
Yeah, so I'm trying to understand,
Oh, I'm sorry. I'll come back to you.
why a statistical model is required here? Because, someone will come, let's say a kid will come between this and this time. You try to do, okay, I'm going to provide it. My kid comes,
Yep.
with this, I'm good. If the kid doesn't arrive, will you send me another, send me a text. Why we need up? Just trying to understand the model, or the statistical.
Okay.
So I got that point, the image one, which is very valid. I mean, that is more powerful, I see, because someone unauthorized person trying to take that image
Yes.
and say that, okay, that is, I see more.
Yes. This is just an example showing the power. Is it absolutely correct? Well, I'm perfect, of course, but this model that may not be, right? It's a working prototype where you kind of see that scenario. I chose to use machine learning first and pictures second. Why? Pictures take a little bit longer to calculate, and there's a fraction of a penny higher cost of them. So I kind of look at that. That's how I get to the level.
One last question. So the hardware that has been used is the Raspberry Pi chip camera.
Yes.
So that it takes pictures.
Yes.
And the door opening is the same chip captures that.
It could be the same chip. In this scenario, I have them separated.
Oh, you have to.
Yeah, I have two separate ones. Why? Because I use a cheesy little $3 thing, and cameras are like $5, or they're 15. There's some price of them, right? And you're right, I'm using a Pi here. Probably a bad example, but there are many other ways of getting that done as well. I show it just for simplicity here.
Thank you.
Thank you. Yes, sir.
Yeah, in this model, I mean, talking about machine learning.
Yes, sir.
And it learns over different iterations and stuff. If you're talking machine learning, is it, I guess, valid to input manual data? Like, let's say, for example, for 6 months, you worked 8 to 5. All of a sudden, you come home one day and they put you on the second shift. Well, with regular machine learning, it's going to challenge you for a while. Is it, I guess, valid under machine learning to manually input new data?
Yes. Or more correctly to say reset. My life has changed. Things have changed. Reset, relearn. That's okay. Because the old model no longer applies. You got 6 years of data. Doesn't matter. Doesn't apply. I sold my house, someone else buys it. You see where things could change, right?
Yeah.
Or, can I answer your question? So you wouldn't want to reset. Did you have a question behind it? Yes, sir.
You have two thresholds, right? You have the 75% where it should be open and the 75% whether it is open
Yes.
or not.
Two different thresholds.
Those thresholds depend on how well the model has been trained over time, right?
Yes.
The more it has been trained, the more accurate that it is going to be. Are those thresholds inputs that you give it, or they also modify themselves as time increases?
I put them as static values.
Okay.
Because it's about, this is acceptable risk to me. Now I can change any value I want. My thoughts are the picture, the cognitive services will learn over time. As I get older, grayer, all kinds of things, right, it'll learn over time. So that will actually do well. Right? So yeah, I can change that if I want. Yes, sir.
You mentioned about a model. Do you have to worry about what the model looks like, or the machine just figure out and build its own model inside?
So remember how you raise your right hand, you're now a certified data scientist? You now have a problem. You have to choose the model you want. I don't know if you have a favorite NFL team or baseball or basketball, but whatever you choose, I promise you someone else in here has a different preference. And I promise you they want to argue you, dare I say, arm wrestle you down why theirs is better. Kind of make sense? So in the data world, we choose a few models. And in the earlier slide where I showed the machine learning, we can say, I want you to give me the model that works best for this scenario. So you have a couple of models you can go after there. I use two-class decision booster tree, and it's a common one people use. In your little certification I gave you of being a data scientist, teaching you models is not part of it, because it's a hard thing to understand. But you use whatever model you want. Some of my people say, all that stuff out there, that's crap. I got my own model. I've got a good friend who predicts NFL teams are going to win. Now, he's lost a few times. And we're not even discussing presidential, his prediction on that. Sometimes the model doesn't work and you have to change. And that's okay. That's okay with that. Yes, sir. This is an NFL question, isn't it?
No.
Good.
Okay. We're talking about Azure, and when we're talking about machine learning or describing algorithms or things like this,
Yes.
how do you describe your machine learning algorithm in a standardized package so I can run it in Azure, but then I don't want to run it there, but I want to move it to someone else's cloud, like IBM's or...
You have total capability.
What
R or
language?
Python, if you like.
I don't know machine language. So how do you describe it? Is there a standardized format, XML based, or whatever?
There are certain models and certain things that go through that are either predefined, open source, or you can write your own in either Python or R language. Any of those models you can take to any open R or any other solution that can run in Python or R languages. Which means, with a little bit of tweaking, you can take it anywhere else. Yes, sir. R.
Okay.
R. Yes. Yes, exactly. That's what these are.
Okay, good.
Not a pun, but these are R.
No, or that.
Yes, sir. Can I answer your question? So, work them anywhere you want.
No, that's XML.
Yes, sir.
To follow up on that, so could you import and export the data that was generated by that model?
Yes. Yes. So the question was, can you import and export the data? Yes. You certainly can, but you have to take it with you. You have to run it. Because every time I open a door, it actually calls a web service to some execution against the model and against the data. Pick it up, take it wherever you'll take it. I don't care. You have to execute it there. That's a fine answer. Yes, sir. Oh, yes, sir. Want to make sure? No, want to make sure people get plenty of chance to ask questions. Yes, sir. What's up?
In your thing, you're using some facial recognition feature.
Yes, I am.
Something that's part of your Azure AI services?
It is. It is part of cognitive services. Yeah, it's exactly what it is.
And it predicted that you were male and that you were, a certain age.
Yes, identifying me is a simple, semi-simple thing to do. Now, in this scenario, I had to tell these 4 people live in my house. My daughter, my son, my wife, and myself, right? And to give it some pictures and train it on who we are. About 6 or 7 or 8 pictures so it knows who I am. So it can statistically say, this picture I just took is with 98% accurate confidence to be this person. Never 100%, but a high level of confidence. Back to the static values, right, of what's acceptable risk.
But it's been trained to identify
Me.
male and the age.
Oh, yeah. Identify male, female, glasses, age. I'm not 42.9. Close. Happiness, sadness. It'll do white. I assume all kinds of ethnicities, but yeah.
Looks like a criminal.
Well, that would be identifying me, yes, yes. Is a criminal, yeah, I get it, I get it.
So
Good
is
question.
this the pre-supplied,
I'm sorry?
pre-supplied module, pre-supplied thing that does facial recognition?
Yes, our cognitive services, we call it FACE, F-A-C-E. And in that scenario, and the same thing, I have the exact same directions how to walk through it. You first create an object, which is a group of people called my family. You add a person there, let's call it Kevin. And then you give it a couple of pictures of me, and then imagine that, you train the model. Then once you've done that, every time we take a picture, you really kind of upload the picture. That's what happens behind the scenes. Say, go look at this picture, you kind of iterate over it, and is that Kevin? And it says, with a 92.7834% confidence, yes it is. Called FACE, F-A-C-E. Yes, sir.
You mentioned the cost of your services,
Yes.
and it sounded like what you said, like if you had 1 million users, it would be cheaper.
Cheaper per. I showed you up there, I'm at $8, right? I'm only one person, one house. I could have run, for that same $8, I could have run several houses. So the cost per house goes down, and that's what I'm referring to.
I'm wondering what the rationale. I mean, I understand like when you buy like bulk components, they get shipped together. It's more efficient, but why is it cheaper to have a bunch?
Why is it that way? I've got Stream Analytic, which is an engine always running, right? There's some cost to Microsoft, right, to buy a CPU, virtual or physical, don't care, it's not what we're discussing. There's some cost to run, there's some cost of power to run one cycle, right?
Okay.
The cost to run a second cycle is not 2x. And I might be able to get 3 things done in that one cycle. That's why, that's the economies of the cloud. That, if you take nothing else from this, that's why we look at the cloud right there. That's the answer.
Cool.
Yes, sir.
You said $8, that's the cost of Azure.
Yes, sir.
Okay. What's the cost of your box? The total box, Because how do you know that's
$3. I bought a pack of these, which was 10, let's say $1 here, so I'm up to 4. I got a Pi, it's a Pi 2 there, $30. Those Pis are expensive. I got a camera. I've got a camera at 15, so I'm at 45. I'm at, let's round to $60. But here's the best part. That's one camera and lots of, one camera and lots of these items there, right? You can outfit many doors in your house with one of those guys. One little device has 16 GPIO pins. So I can, monitor many doors in that scenario. So relatively inexpensive for that.
Thank you.
Yep. Any other questions? Yes, sir.
I had one. Has it been tested on twins? Being able to tell
Yes.
twins apart?
I have a good friend, Terry Gore. He has a twin. Now he says he's a better looking one. I disagree. Identical twins. It knows the difference.
Yeah, I have identical twin cousins. That's what made me think of it.
Yep. Give it a try. Yes, sir.
So what sort of signal processing capabilities does it have? So I would say, facial recognition is the first, but you might do sound. You
Yes.
might do other things like motion gait analysis and,
Yes.
and other things. Are these coming or do they exist today?
A good portion of them exist. Sound exists. Picture exists. Video exists. Those are the common inputs. We look at that. If I want to calculate the difference of 2 pictures, right? I had a customer say, I want to look at this area and I want to calculate the change over time. Think about a construction site. Think about, are they on track or not? That's an interesting question. How much more of the building's been built? Now, construction is a bad example because you normally build the outside, then you do the inside, but just go with this example, right? So they're able to say, calculate the difference in this scenario. Let's say you're producing something we all eat, and it comes from raw materials, be it a potato, a chicken, or something, right? We can use that computer vision to look at that and to try to start determining these are bad. Bad chicken, bad potato, bad whatever, right? We can start using that capability to detect things that we might not see. right? I've got a manufacturing plant right now. They use like 4,000-degree ovens to cook kind of things, right? When those come out, if I scan it with an IR camera, I can start to see some of the heat signatures. I can figure out, was that an even cook? Or do we have a problem in there? These are all the scenarios of what we call cognitive services that they light up. It's a pretty cool capability, I think. Yes, sir.
I'm just wondering, like you have an example of the Raspberry Pi, the camera. How about the existing, for example, the Nest Cam? Do you have those?
Yep. Really, the Raspberry Pi, it's an interesting device. I've had them forever. You guys all have them, I'm sure, if you're as nerdy as I am. It does one thing only for me. It takes a picture. That's really all it does. I've got another example where I actually use the goggles that have the camera in them. Just don't care. Give me a JPEG photo, and I'm good. I just don't care. And if that's the case, and that is the case, what if I tapped into your home video security system already at your house? You already have cameras set up now, don't you? Exact same thing, right? There's a way through JSON of talking to a lot of those systems, say, give me a snapshot or a picture of what you just saw. So we can do most any device like that. I'll be to you, I promise you. Yes, sir.
Is there a thing like too much data or too much training?
So a part of a few things of my remember, you guys are all now deputized data scientists now, right? There's never too much data. All data has value. Data must stay in its native format. Don't try to force it into a schema. You know, you say all data has value, so store the whole thing. You don't know what questions you're going to ask yet. Right? You just don't know the questions. You know some of the questions, but you don't know all the questions. You may later say, how long was the door open at Kevin's house? That may tell you a lot, right? You never knew that question. You came up with that 6 years later. I got the data. I can look at it. So, if all data has value, and it does, we want to store it in its native format. Don't force a schema, don't cleanse it, don't do any of that stuff. We'll do schema on read, which means that I don't know or care with the schema. It can be binary. Don't care. Okay? Has value, then it sounds like I'm talking about a lot of data, right? And I am. If that is true, and I believe it to be true with all my heart, I want to store it as cheaply as possible. That's where you look at things like Azure storage, that kind of scenario, 3 cents per gigabyte. That kind of makes sense, that scenario. So yes, it does have value. I think that putting year in my model has no value. I could be wrong. Yes, sir, in the back.
I think the home security and home automation scenario is a good example of machine learning on an IoT device. My question is there any interface or API to the voice recognition intelligent agents in the Microsoft Cortana, in a laptop or a smartphone?
Yes and yes. Yes to all the above.
The Amazon Echo and Google Home Assistant have become very pervasive.
Yes.
And it seems like that in terms of home automation, that the SmartThings standard from Samsung and Cisco is taken over in the middle to talk to every device in the home from those intelligent agents. It seems like, are you supporting the Amazon Echo and the Google Home Assistant, which have open API?
Yes. Yes. We look at cognitive services to be that open API that you can consume with anything. Our life changed drastically when Steve Ballmer left our company. Right? Good, bad, or different, doesn't matter. I'm not here to praise or to hammer the man. Really like our new guy, Satya Nadella. That's when we started putting partnerships with people who used to be our biggest competitors. Okay? He looks at it saying, I don't want to force Windows. Windows is or is not a great OS. That's up to the masses to decide. But wouldn't it be great if Azure had some capability anyone could consume on any platform? We write SDKs all over the place now. C and Linux and Windows and C# and Java and Python and all these silly words, right? We do all those things. We just don't care. You know, we want you to be able to consume our capability any way you want. Over a third, it's really about 30 to 40% of everything running in Azure is not on Windows. I didn't say VMware. That's not what I'm saying. I'm talking about the hypervisor. I'm talking about the guest OS, right? Those things. About a third of what runs in there is Linux. That's the new Microsoft. That's who and what we are, right? So yes, and we do want to partner with the Amazon Echoes, those kinds of things. It's something where we can write amazing apps that consume all this goodness and put it on whatever platform we want, whether it's wearable, an Echo, a phone, a home security system, something I can't imagine, maybe even, dare I say, a connected car, right? All those things we bring to bear there. Yes, sir.
So, if somebody were to come up with some sort of detector that's new, well, maybe not new, but like, let's say the home security system, okay? And you put like a radon detector in there as well.
Love it.
Okay. How easy is it would it be to tell your model if you're adding like a completely new thing to the mix? Is it treated just like any other input?
Exactly. It's just another piece of data, period. Nothing magical about it. Right? Door opens at 1 or 0 in my world. Radon or carbon dioxide, more of a percentage, right? Not exactly binary. It's okay. And maybe if it's trending over time, and that's how we do things like predictive maintenance. We can predict when certain things are going to happen because we see it trending up. Think about your hot water heater as an example, right? We probably all have something like that, right? Ignore for this conversation tankless. Let's say you have a tank hot water heater, right? We can look at how long it takes to heat it up. We can look at the changes that's happening in the water coming in. We can predict when it gets very inefficient, dare I say, predict a failure. Not absolute, but really does a great job of predicting those kinds of scenarios, right? We call that predictive maintenance. Really interesting scenario, but if we can look at things like, dare I say, airplanes, and pull data out of them, we can understand what's going on and predict failures. So that's kind of a cool aspect of that. So yes, any piece of data you're looking at, now that you're all certified data scientists. Yes, sir, you had a question up front, sir?
What kind of protocol are you using between your devices and the server?
I'm using MQTT for the box there. I'm using AMQP for this one over here. I don't like HTTP. Yes. I use those two, which had a concept of publishing and subscribing data.
What are you using AMQP on?
That Pi device, Raspberry Pi.
Why did you choose that instead of MQTT?
More efficient. I didn't choose MQTT. It was chosen for me. I used an open source library on that one. Okay. Just okay. Right? So that's that scenario. When you use those real protocols that I'm talking about, subscription and whatnot, for IoT devices, another thing lights up we didn't even think about, device management. In this scenario, I mean, I can push down the firmwares to it. And anyone who's done infrastructure management, like desktop PCs or whatever, you have some kind of we used to call it SMS or config man, or it doesn't matter which one. You know all the desktops, you know this is Bob's desktop, and IoT, that all your thoughts go out the window. You have millions of devices, okay? So you approach it very differently. You say, you kind of illustrate what you want to happen. If a device shows up with version 0.07 of the firmware, I want new stuff to be automatically laid down on it, right? You kind of illustrate what you want to happen. You don't count them, you don't inventory them, you just say, when these things happen, I want this corresponding event to happen. So we have device management as well built in, which is firmware in that scenario, for simplicity's sake. Or configuration, right? That one's now pointing to a particular server. Maybe I need to change it to a server in Europe. Configuration.
So but over MQTT, effectively you're sending binary. I mean, you can send JSON or anything you want.
I'm sending JSON. Now, JSON's not the most efficient from a wire perspective, but I kind of like JSON.
Now, are you sending it, is the Azure machine learning system receiving those messages directly, or are you receiving them into a Node.js app or something?
Great question.
Converting them and processing them into that through an API service?
More to the second thing you mentioned. We terminate everything we'll call our Azure IoT Hub. That's the entry point, exit point of all devices, period. Done.
That's a broken event.
And then that stream analytic, that in-memory thing, says, oh, this is a door event, or a radon event, or this event, and it sends it out to machine learning and says, should this have happened? Door's open. I don't know if that's good or bad. You tell me, Mr. Smarter Than I Am.
So that thing is subscribing to the message from the door sender.
Yes.
Translating the information for the email sending it to the ML and getting a result and then presenting it back.
You've just described half that whole model. Took me a day to do it, you did it in about 10 minutes. Thanks for making me feel bad. Any other questions? Oh, let me go back here. Yes, sir.
So I'm hearing about half and understanding about half of what I'm hearing.
Okay.
So if
Do those match, or are you understanding nothing?
I'm getting this much.
Fair enough.
So great demo, by the way. How does, if I'm the alarm guy who had the old school model with no machine learning, how do I get started to take advantage of everything you want?
KevinSaye.wordpress.com. Simple as I can make that. Kevin, S-A-Y-E, .wordpress.com. I assume we can share that URL out. If not, you'll write it down. I'll have it up there. Yeah, so that walks through everything I just showed you, and it teaches you how to be a data scientist with click-throughs, right? Also shows some pretty other cool things. As I said, I am a nerd, and I do a lot of soldering and do a lot of crazy, stupid stuff, right? And my wife puts up with this, so life is good for me. Any other questions? Yes, sir.
What kind of security protocols are you running on?
Great question. Security. I'm surprised it took this long to come up. It's okay.
Yeah, me too.
How does Microsoft use security of IoT? Well, I'm glad you asked. We look at it from two perspectives. First thing, all these devices talk to our Azure cloud. Trust me, we have security in the cloud down pretty good. Nothing's absolute, but we understand that. We get that. We understand that pretty well. So when all that happens up there and it's in a PaaS scenario, right? Platform as a service, no OSs, no my antivirus up to date, firewall, blah, blah, blah. None of that junk happens, right? It all happens there, very inexpensive, and we control the security there. Secondly, in the SDKs we write, we focus, we bring our SDLC, Secure Development Lifecycle, to bear to make sure there's no backdoors, that kinds of scenario. We view these devices should not listen on the wire at all. They do one thing. They boot up. They do whatever sensors they do. They talk to IoT up. Only. Done. In that security stance, it's a pretty simple story, right? No open protocols, no SNMP, no blah, 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 blah. None of that stuff happens, right? So that's kind of how we view that scenario. Maybe we're wrong, but we think that makes sense. That's a very little security attack surface, right? And our SDKs we review, we expect developers to apply some level of security and scrutiny to what they're doing too. To not write some backdoors or whatever, right? But that's your choice, right? You would expect large organizations to work through and to say, yeah, we have some kind of code review cycle to make sure there was not a backdoor put in there. That's kind of how we view that, whoever asked that. Any other questions? Yes, yes, sir. I'm going back to you next. Yes, sir.
So the IoT hub, is that part of the service? How do you charge for that?
Great question. Yes, it's part of the service. It's a PaaS, platform as a service, right? We have 4 SKUs. One's free, and then we have S1, S2, S3, right? It's meant for millions of devices. You really say, how many devices am I going to have, and how many messages are they going to send? And then you scale it appropriately. Then you have a couple things. So it's paid or charged on your usage pattern, right? So it's not absolutely per message. It's kind of where do I move the needle to as far as I want S1, S2, S3 to handle that kind of load I'm looking for. That's really what we look at. Starting at about $50 a month, right? So that's kind of an interesting scenario there for that point of view. Yes, sir.
Yeah, so when you send something information, whether it's open or that kind of machine learning decision, you said that you catch the cloud and cloud reply the answers, right?
Yes.
So, do you think, did you ever think about that when there was network interruption, something like that? So somebody comes in, at that time network doesn't work, you cannot send and you catch the cloud.
Yep. So the question is about, we receive data on the cloud and man in the middle or anything else like that, we mutually authenticate. There is no man in the middle. But we do support, it's going to sound crazy, a proxy. Proxy is not really a man in the middle. Some people have that need for it. I don't like them, but some people have the need for it. And things like Linux and Windows understand the proxies, so do real-time OS devices. But you'll take a connection, you'll make an HTTPS connection to us, right? So we have encryption transit, right? So things are, the wires encrypted from a TLS perspective, right? And we also have the concept of a key, we call it a SAS token, right? Where you'll take an encrypted token where only you can authenticate. So that allows non-authenticated people, that precludes them from talking to us, and that encrypts the channel between the two of us. On top of that is JSON, right? Well, you can do anything you want, but JSON is what I like. You can also encrypt the JSON payload, if that's what you want to do.
Yeah, but what I'm asking is that if there is network interruption, so you cannot send the request to cloud. So how can you get that information, whether it is that information? So what I'm saying is there any solution? Did you ever think about the solution when there is no network?
Yeah. No connectivity. Well, it's kind of needed, right? But there's more than one way of doing connectivity. Anyone here know what LoRa is? Interesting. Interesting stuff, right? It's for those who don't, we all understand cell or LTE or what the heck you want to call it, right? LoRa is very different. It's a device talking in a low power scenario, anywhere from 2 to 20 miles, where they kind of talk to each other, but they talk to a gateway. And that gateway converts from LoRa into internet IP connectivity, right? Things need some level of connectivity. Whatever they're doing, 900 megahertz, just don't care the connectivity. But we have the concept of what we call a field gateway. The field gateway is a device in the field, wherever you happen to be, that's talking natively in those devices, whatever they're talking, and doing what we call protocol translation. 900 megahertz, maybe an insecure scenario, and it makes a secure connection into Azure. So we address things like that. If you have things that are loosely connected, say I got a truck, right? I got, let's say, cell coverage in a truck, and I drive in a black area, meaning, black's probably the wrong word, in an area where I don't have the good connectivity, right? That device is going to store up all of his communications. And when he comes back into communication, he's going to replay all the data he had, preserving date time.
Yeah, I think that is also in the AWS IoT also has that kind of connection problem. Solution, but when you need a real-time machine learning decision, you need to get that from the cloud, right?
Yes.
When somebody comes in, you open the door, so you need to get the result, the machine learning decision from the cloud. So with that is no network.
Yeah, so the lack of network's a challenge, right?
Yes, so I'm asking if you ever think of that kind of solution, that kind of some temporary data is stored in locally or that kind of thing.
Yeah, well, I think that's where what we call a field gateway comes into play, right? Those devices can store data.
I think what he's asking is.
Oh, yes,
How
I
do you
missed the
make
question.
a thing that can do local decisions so that the network is not required? When it's not required, when it's not there.
Also, part of that field gateway, we have analytics in there, decision-making capability. Not as strong, but some of it, right? So, yeah, we're pushing more of that decision-making down to the device, down to the gateways, down that area. That's where we're evolving the SDKs right now. We're giving them intelligence.
You can push the machine learning model down into the pie. Leave the figuring it out part up in the cloud, but the answer part.
Be careful there.
But the decision based on the multiple model is in the cloud, so local cannot design, right?
Well, I think if there's a sort of like a compression algorithm, you need a lot of horsepower to compress it, but not so much to decode. If the algorithms for the machine learning can be ran as an algorithm process on the pi, the learning part for figuring out that, the inputs to that algorithm can be done in the cloud where there's more power.
Simple algorithms, yes. You start having a physics problem and a horsepower problem. That pi can only run so fast, right? That's what you deal with. This thing, 120 megahertz, right?
The problem is the data. The model data is in the cloud.
Yes.
Not in the local.
Yes. No, you have to kind of solve that problem. Connectivity is what enables a lot of this. But when you don't have connectivity, you kind of have to deal with something different. Yes, sir.
Yeah, I didn't really hear the question there, but.
If I answer most of your question, I'm here to you, I promise. Okay, yes, sir. Your turn.
No, I didn't really hear the question. We're talking about two completely different things here. You're talking about Azure and cloud and platform as a service offering from Microsoft, and we're talking about now a completely different thing that I mean, from an Azure cloud point of view, you don't really care about the technical details of what protocols we guys are using down on the embedded devices and communications up towards your platform, et cetera, including what you talked about security aspects. It's up to us as developers to figure it out. I mean, I'm just trying to figure out where we were.
Generically speaking, I would probably agree with that, but we know that this doesn't happen overnight, which is why we write all the SDKs.
Yeah, no, of course. I mean,
Right, 'cause you have to
provide those,
But yes.
support those features as well.
Certainly.
But it's not core of what Azure is. I mean, you're more agnostic
Certainly.
in terms of protocols, and as long as you get up on the highest level.
Certainly. And in the weirdest of ways, the question I thought might have been asked about putting calculation down in the devices, right? That's kind of going anti-Azure just for a second, right? That says do some calculation, not in our cloud. And we seem to be okay with that. Once again, things changed drastically once Saye took over, right? We're really just trying to solve problems. Really what we're doing. We see the power of the cloud. I've got a lot of customers say, I want to do something here. I want to do UDP across the internet. What? If that's really what you feel you must do, we can do it. Yes, sir.
So when you send a data or command back to the IoT device,
Yes.
you have to open ports in the firewall for that?
No. The protocols that we use, HTTP, like MQTT, AMQP right now, they have the concept of subscribing, so they're always listening. Imagine, for lack of a better word, a persistent TCP connect. That's really what that is in that scenario. We even support.
It's always an ongoing TCP.
Yeah, we even support over WebSockets. So that's an interesting. Anyone knows about WebSocket? That's an interesting change in that scenario.
What about WebRTC?
What's that?
When are you going to get WebRTC?
I'm not familiar with that. You've exceeded my capability again. Any other questions I can help with? Yes, sir. You. Yes.
I understand your model was fine with the normal family members and the code strangers. But what about the occasional visitors? They might give you a visit once in a while. And how can the model work with that kind of scenario?
This proof of concept doesn't understand that. But it could be as simple as when someone comes into my house, a neighbor, it texts me, do you authorize this person? Oh yeah, that's my neighbor Sonny. Yes.
Yeah, because we don't want to be tasing the wrong people.
You know, there are other ways of going at this. Is a prototype, right? If you can dream it, I dreamt this, or nightmare this, however you want to call it, right? Very short amount of time. It took me longer than Visio than it took me to dream it up. Then it took me less than a day to put the whole thing together. Okay? Dream it. When you dream it, IoT, I spent last weekend at a entrepreneurial group. I told you I don't like working the weekends. I don't. In fact, what I did. An entrepreneurial group focused 100% on IoT. Everything they brought to the table is IoT based. Okay? They have some pretty great dreams. I love it. And I'm there to help them figure out how to make that real. How to put all these things together. They focus a lot on healthcare. They focus a lot on parking problems. You know, when you're driving, there's a parking spot available. All these kinds of scenarios. Even drones were brought into this kind of concept, right? So pretty interesting, pretty cool stuff. IoT, I see, is very transformative. Lots of things are happening there. So if you can dream it, add it in there. I love it. Any other questions I can help with?
Where's the definitive reference on this?
Well, I'm sorry, what's that?
Where's the definitive reference on this? Is there a good book you can recommend?
For
cognitive learning.
For cognitive services. So, great question. I've been involved in writing many books, been reviewers, all kinds of stuff. I don't know if books move fast enough.
So where do I go?
So cloud services are very interesting.
Preventative maintenance.
I'm sorry?
Preventative maintenance. Where do I go to figure out how to deal with that?
Oh, that's an easy one. That's an easy one, yeah. So kevin.saye@microsoft.com. Shoot me an email. I'll send you kevin.saye@microsoft.com.
S-A-Y-E.
Yes, sir. Add the E. Yep. And I'll shoot you some info on the preventative maintenance kind of stuff. but it's really centered around a couple of use cases. It's not about technology per se, it's about, I've got this business problem I want to solve. How might I solve that? How might I apply the right model in machine learning to help predict when's this brake pad going to wear out? And that's exactly what we drive to. Once again, remember my story, I'm sticking to it. Day one, it's a horrible solution. Day 90, day 180, bring me data, and we got some good stuff. Any other questions I can help with?
Another place to consider is Udemy. It's an online educational thing. They have a lot of stuff on machine learning classes that you can take.
Just curiosity, what is the base engine for the machine learning in Azure?
What is the base engine? We acquired a company called Revolution Analytics, and it is based on OpenR. OpenR is an open source solution on that. I think that actually is running on Linux, just what that happens to be running on, and it's the engine on top of that. You want to learn more about Python and R and machine learning? OpenR. It's a great place to begin. Okay, and that's what it's based on. Yes, sir.
Have you seen any applications of IoT or machine learning in the music space?
You know what? I haven't. You hit me there. I see lots of stuff. Healthcare is very strong. Mechanical, manufacturing, transportation, music. Haven't seen it. Even my entrepreneurial folks, no one ever mentioned that. And I had 23 different groups there.
I can answer that. There was a program on NPR last night about a new AI application for music called JukeDeck.com, and it'll write free licensed music for any application.
Cool.
JukeDeck.
You can also look up a guy named Gil Weinberg. He does machine automated music creation and stuff.
Any other questions?
Germany did that in the 80s and I didn't like it, so don't go there.
Again?
They did it in Germany in the 1980s and I didn't like it, so don't go there.
So we got 99 Red Balloons.
Yeah, but that's the one that is good.
That German or Russian?
And Dieter.
Any other questions? All right, well guys, I do appreciate your attention to everything. I'll be here for the rest of the day. I got one more drink ticket left, so I'm in.